क्या करने वाला भैया?
Good morning, sir.
Good morning. How are you?
Yeah, fine, sir. Thank you, sir.
Wonderful. Good morning.
Good morning, sir.
Good morning, Shiva sir. How are you?
Bilkul ठीक हूँ, sir. Thank you. Thanks for
I'm
coming.
not sure that I'm in the right frame after traveling whole night. Whether I'll be able to deliver the way it should have been.
No, it
Am I
will
on
be.
there? I'm on the public platform now? Or what?
Yes. Yes, sir.
Yes.
Yes. So, shall we
We are
start?
live. Shall we start, sir?
Yes,
Sure,
sir.
sure.
शुरू करिए अशोक.
Yeah, thank you, sir. Good morning, everyone. I'm Ashok Kumar, Director, Wireless Access. I'll be moderator for this session. So, respected member services, Deepak Chaturvedi, sir, respected Senior DDG and Head NTI Pred, UK Srivastava, sir, and our expert speaker, Mr. Zahid Gariali from Parallel Wireless, and Mr. Hiren Joshi from Rakuten, Japan, and Mr. Ramu T from Lekha Wireless, respected DDGs and senior officers from NTI Pred, DOT headquarters, TEC and field units, my colleague directors, and all the participants who have joined this particular webinar. So, good morning to all of you and very warm welcome. I request now my DDG B. Sunil Kumar sir for welcome address.
So, thank you, Ashok. Respected member services, Deepak Chaturvedi sir, Senior DDG and Head NGA PRIT UK Srivastava sir, my colleagues in NGA PRIT, and all the eminent speakers, Zahid from Parallel Wireless, Hiren Joshi from Rakuten, and Ramu from Lekha Wireless, distinguished audience from across India, from academia, from DOT, and from industry. All senior officers logged in. A very good morning to all, and good afternoon to Hiren in Tokyo. So, in fact, Open RAN technology is one of the most talked about technology in the recent past, not only in technical forums, but also in diplomatic forums globally as well. I would say that the technological sphere in telecom has become so huge and vast, and it has become imperative for the openness to creep in all facets, in all interfaces, so that innovation can thrive. So it was the need of the moment, and Open RAN technology has come up in that context. So in NTI also, we have been endeavoring to keep this in all our training programs on 5G as well as in mobile, as on all mobile aspects. And the current webinar content also has been chosen. The webinar template has been chosen with an idea to give 3 participants with diverse roles. Mr. Zahid Gadiali from Parallel Wireless is not only he is senior director in Parallel Wireless, which is a company which has Open RAN in its DNA, I would say, with the entire portfolio of all Gs, 2G, 3G, 4G, and 5G in its product portfolio from the Open RAN philosophy. He's also a prominent blogger, and he's a technologist per se, and I mean, very renowned trainer as well. So we'll start with his session, and later on we will have Hiren Joshi. Of course, Rakuten is known to all. It's a poster boy or a most well-known example of or demonstration of Open RAN in public networks. So we'll really cherish the second session from Rakuten. And the third, of course, is from Ramu Srinivasaya, and he will be from the Indian ecosystem of Open RAN, and he's an exciting speaker as well, apart from being a technologist himself. So I'm sure that we are going to have good sessions tomorrow. More details will be shared by Ashok. And with this background, I really welcome our member services, Deepak Chaturvedi sir, to our midst. He has been handholding us and encouraging us in all our endeavors, let it be in the institute itself or in open online forums. So thank you very much, sir, for coming, and welcome to you, sir. And secondly, of course, our senior DDG UK Srivastava sir has been the prime mover or the prime force behind all whatever we do in our institute. So thank you very much, sir, and welcome, a hearty welcome to you, sir, as well. I welcome all the three speakers, eminent speakers on the right, and all the three have agreed readily as soon as we invited and suggested their candidature for this. So I really welcome, despite all their busy schedules. Ms. Said has to attend the 5G forum in London soon after some time. So early morning he is attending from here, and Hiran also from Tokyo, and Ramu, of course, is very busy within India itself. So really welcome to all the three participants, and welcome from the part of the institute. So I welcome all the audience from across India, academia, industry, and DOT officers. Welcome you all. Hopefully we all will have a very productive session today, and quite a knowledgeable one too. Thank you, Ashok. Over to you.
Thank you, sir. We have more than 200 participants watching this webinar, sir. So proceeding forward, sir, I'll just introduce the topics which we'll be covering during this webinar, and about our expert speakers. So there are three topics, sir. The first topic is why Open RAN and the ecosystem readiness. This session will be taken by Mr. Zahid Gariali from Parallel Wireless. Second session is about the Open RAN experience, which Rakuten Japan has done. So Mr. Hiren Joshi from Rakuten will be taking this particular session. And the third session is about the Indian perspective of the Open RAN in India. So that will be taken by Mr. Ramu T. Srinivasaya from Lekha Wireless. And all these, our three eminent speakers are already on to this webinar. You can see even the video. I request even Ramu and Hiren also to kindly open your video for some time so that everyone can see you. Just to introduce about Mr. Zahid Gadiali. So he's a senior director at Parallel Wireless, and he's also principal analyst and consultant at 3G, 4G. He has over 20 years of experience in telecom industry, and he's a trainer. So you can see a lot of YouTube video, a lot of blog. He keeps on writing related to the mobile technology, especially 5G and 6G nowadays. So he's a kind of a very, very good trainer also, and he's known worldwide. Our second speaker is Mr. Hiren Joshi. He's head of operation of mobile services at Rakuten. Particularly, he looks after the cloud RAN of 5G, 4G, packet core, BSS, OSS. And so he is kind of responsible for organizational setup, network architecture, etc. So he's a head of operations of Rakuten Mobile. So welcome, Hiren Joshi sir. And our third speaker is Ramu T. Srinivasaya. He is actually founder director of Lekha Wireless. And Lekha Wireless is, of course, working in Open RAN field. And prior to coming to this company or founding this company, he was working in Cisco. He was part of the Cisco initiative related to the WiMAX at that point of time. So with these introductions, now may I request Head of NTI PRIT, Sri UK Srivastava sir, for his special address on the occasion. So over to you, sir.
Thank you very much, Ashok. Shri Deepak Chaturvedi, Member Services, Digital Communication Commission. Speakers in today's webinar, Shri Zahid Gadiali, Hiren Joshi ji, and Shri Ramu Srinivasaya. Participants in this webinar who are officers from various units of DOT, including LSAs, TEC. I find some officers from NCCS also joining, TRAI, CDOT, BSNL, MTNL, and my colleagues from NTI PRIT. Good morning to you all and welcome to this webinar. I especially welcome our member Shri Deepak Chaturvedi ji, who was traveling last night, and I made personal request to him to join this webinar and bless and inaugurate the webinar, and he has kindly agreed. So most welcome, sir, for participating in this inaugural session of the webinar. I also welcome the eminent speakers all of them wonderful trainers and personalities. They should also be happy that we have in excess of 200 participants eagerly waiting to hear them and learn from them the technology, nuances of technology. All the participants, welcome to you. I'm sure that it is going to be a very good webinar for you all. And then last but not the least, my fellow officers from NTI-PRIT. Everybody welcome. You all know that this Open Radio Access Network, or ORAN, has become a hot topic in wireless communications, with many service providers anxious to deploy them in next few years. So based on the virtualizing network functions between the radio and telecom core, Open RAN will spur innovation, cut costs, and offer great opportunities for differentiation among both operators and equipment vendors. Of course, despite the tremendous progress that has been made in such a short amount of time, including the creation of Open RAN Alliance reference architecture and at least 23 for 24 specifications, the industry is still a long way from meaningful Open RAN deployment. Of course, we hear a lot about Rakuten network, and it has been the first network. So we have a speaker today who will be talking more about it and also about further deployments world over. This Open RAN Alliance, I'm told, is hardly 3 years old. So still it has a large membership, maybe 30-40 operators and more than 250 contributed companies, including network equipment manufacturers, software vendors, chipset manufacturers, and test equipment companies. Many of them Indian companies who are very much deeply entrenched in ORAN Alliance. So many of those companies have joined just within the past year. I'm told that this has happened. So the momentum in Open RAN is really intensifying. The Open RAN interoperable architectures and virtualization are both core to the definition and vision of Open RAN. Both are within sight but remain work in progress, as I was telling earlier. A dozen of companies throughout the world now develop Open RAN equipment based on nearly 24 Open RAN Alliance specifications released so far. Like the emergence of any major disruptive technology, the process of refining these specifications moves at its own glacial pace. So this will take some time for all the blocks of this jigsaw being in place. All said and done, the protocols and interfaces are being continually refined in pursuit of goal of true interoperability. So I hope that today's webinar will provide us the update on the status so far. I'm sure that the webinar will be useful to all the participants. The NTI-PRIT Wireless Access Division has diligently selected the speakers, as you have seen their CVs, so for this today's event. And we are grateful to them for consenting to be part of this event. With these words, I once again welcome Member S, eminent speakers, and all the participants in this webinar. I hope that it is going to be a very successful day to you all. Thank you very much. Back to Ashok, please.
Thank you, sir. And proceeding further, sir. So now I request our member services, Sri Deepak Chaturvedi, sir, for keynote address, blessing, and finally declaring this webinar open. So over to you, sir.
Thank you, Mr. Ashok. Good morning to everybody. And ladies and gentlemen who are attending this webinar and my friends across the telecom fraternity. It's a great time to be this topic, because this Open RAN is something which is really emerging and very challenging. And the occasion of arranging this webinar on this topic, which is Open RAN opportunity for India, is a very, very timely, very, very critical subject of all the people who are engaged with the telecom sector, particularly who are approaching for the development in 5G era and onwards. At the outset, I would like to congratulate NTI for arranging such a wonderful webinar on a timely and critical subject, and that is such an important topic, which is going to build our telecom network in emerging time, and its requirement is definitely has come. It's the COVID pandemic taught us the importance of technology in our lives. The technology and progress made in the digital transformation have proven to be great advantages during the pandemic. The telecom industry is now looking forward to accelerate 5G deployment with new and more cost-effective ways of deploying and managing the network quickly. This is where the concept of an open and virtualized mobile infrastructure. I'm sorry, my throat is not probably keeping with me. Open radio access networks, open RAN becomes so critical. Friends, as you are aware, open RAN refers to the movement in wireless technologies to disaggregate hardware and software and to create open interfaces between them. This newly created multi-supply ecosystem uses cloud technologies, network virtualization, artificial intelligence, AI, machine learning, open APIs, and many of other associated calling cards of 5G and cloud era communication. I'm sorry. I'm sorry, partner, please bear with me. My probably.
Maybe, sir, if you have a problem, you can just conclude, sir, and declare the session open, sir.
Okay. This open RAN, I'll cut short the call because probably my throat is not keeping up with the time. I relate, this topic is something like Mr. Srivastavji or those who are from the late 70s, early 80s realize is akin to dedicated switch network to the open network where the common sources were being utilized, which led to the development of ESS5 technologies or the common control system technology from analog time. This open S is something like that, where the technology are agnostic to the supplier, they are agnostic to the standards, and the interface will to the various part of this thing. Friends, I would have spoken much more things, but probably this is signal to say when we have such an eminent speaker who are the worldwide acknowledged for their capacity and the capabilities, as already mentioned. As I see the three great speakers are lined up, Mr. Zahid, Mr. Hiren Joshi, and Mr. Ramu. So I'm sure the time is saying to me from the God signal that you should stop speaking and let the expert take the dice and speak on the subject. With these words, I wish this webinar is successful event for all the learner as well as the trainers, and I wish a wonderful time ahead for all the participants. And I'm sorry I could not speak the way I should have spoken. And I must congratulate Mr. Srivastav and his team of Integrator who are taking every day a new topic, and every week I'm seeing a wonderful topics they are taking for the fraternity of telecom to learn and come up with the requirement of time. With this, I declare this webinar open.
Thank you, sir. Thank you, sir. Thanks a lot. And proceeding further, sir. So, yeah. Proceeding further, sir, so the first topic is why Open RAN and the ecosystem readiness towards the Open RAN. So may I invite Mr. Jahid Garyali from Parallel Wireless to kindly deliver his session. So over to you.
Ashok,
Thank you. Thank you. Thank you,
Yes.
Ashok. Thank you, everyone. You can see my screen and you can see me. I'm looking forward to actually hearing about other speakers too. I'm assuming it's still morning, so good morning, everyone, and good afternoon. So I think one of the things which the pandemic did is it basically made us more flexible, right? Especially with the things like having online, Zoom calls or team meetings. So you can actually have, somebody from London, somebody from Tokyo, and, a lot of people from India, right? So it's basically becoming like a global seminar kind of thing. So yes, so I'm actually also worried a little bit about my throat. So I had some ginger tea, as you probably saw me having because it's a bit early. And I'm going to actually do a scene setter and talk about the just the Open RAN and the ecosystem readiness. So a lot of these are actually my views, but I've sort of discussed with a lot of people in the industry over the years. So, and they agree. So I would like to think this is the view. So, right. So just very briefly about me. As I was introduced, so I work as a senior director in technical and innovation strategy in Parallel Wireless. I've been with them for over 5 years. Uh, Over 1 year full time, but before that I was like not full time. So I look at a lot of things, including what's going on in the market, what our competitors are doing. I do analyst relationships and a lot of different kinds of things, right? I get involved with. But in addition, as it was said, right, I have another role, which is basically I do a lot of things with my own hat, which is the 3G 4G. So um, I don't know if I can actually no, just bear with me for a second. I'm just trying to. Um, so yeah, so for people who actually know, right? So 3G 4G is basically just a resource center, right? I started this 3G 4G website back in 2003, and then website wasn't convenient, so I started the blog, right? Then it sort of diversified into lots of different things, the operator watch and things like that. I have a YouTube channel, as some of the people already probably know. So yeah, whenever you are bored, you run out of things, you run out of ideas, you can actually go through any of my channels, including 6G. And just so that you think I'm not serious, I also have a 6G cup, right, which is on which I was having my tea. So 6G tea early morning. So yeah, or you can actually just search across all my channels here. So if you do just like anything, you will find probably like loads of links. So it's actually funny. So the ORAN Alliance, right? It sort of got founded um, in 2018. So when it was founded in just before MWC 2018, what happened is people were not really sure what exactly Open RAN really is. So every everywhere you go, every time you hear somebody, they will basically be talking about like, well, Open RAN, we have to define it. So back in 2019, just before Mobile World Congress, I made a very basic tutorial on what Open RAN is, right, to start discussions. And also because as Parallel Wireless, we were talking about Open RAN since 2016. So this is when Telecom Infra Project, which is a group by Facebook, Connectivity, they they started the Telecom Infra Project, and one of the groups was called Open RAN, right? So we will look at it very briefly. And people wanted to understand exactly what Open RAN means. So I made this tutorial, I put it on YouTube, and yesterday I checked, right, because I was doing this presentation. So it's got around 50, 56, 57,000 views till now. So, and and I've had so many discussions based on that. And what I see is a lot of literature which we find on Open RAN has sort of been inspired by that. So which is actually quite a good thing to basically see like, okay, you know what, people agree with the things you say. Right. So jumping into exactly, you know, the whole thing, and I'm doing a scene setter. So for some of the people, some of these things might be a bit basic, but you know, they'll find the later part a bit more useful. So what we have is, you know, if you look at the figure on the left, right? So this is the traditional base station that existed during the 2G and 3G days. So the big issue with this approach used to be the RF cable, because the RF cable meant like there are RF losses. So what you needed is you needed this RF cable as short as possible. And it was not always practical, because if you wanted to have a tall mast, you can't really put the equipment up there. So you know, if you're putting the equipment at the base, what you want to do is you would want to instead have like a lossless connection between like the this part, which I call as the, like, you know, the cabinet. So which is I call as the BBU plus RU. You want to have like a lossless connection from here to up here to the antennas. And this is what actually, you know, basically made us move into the new architecture where we would have a fiber connectivity between the baseband unit, right, and up to the RRU or the RRH. And you know, so when you have fiber connectivity, you would run the CPRI protocol, right? And basically at this point, you would convert it back from, if you're talking about the uplink direction, from digital to analog, and in the downlink, it's basically, sorry, so downlink direction where it's going up. So basically the digital to analog, and in the other direction from analog to digital. So this protocol was CPRI, and the problem with CPRI protocol, as I'm sure most of you know, is it's quite a close protocol with a lot of vendor proprietary information. So it's not always easy to have a baseband unit and the RRU from different vendors, right? You may have it from different vendors as long as they have done a lot of interoperability testing and they have agreed how it's going to be. But it's not like plug and play. So you know, you can't just replace this one and put this RRU from somebody else. And this was the big issue. So, you know, if you look at the traditional approach, which we call as the, you know, with the tight integration, right? So we are going to just look at some of the terminology. So in the tight integration, you have basically this interface is a proprietary or a closed interface. Okay. And, you know, making the front hall open using, you know, eCPRI is basically the most basic open interface which we are talking about. So, you know, you can call it like a radio hardware disaggregation or horizontal openness. But you have to actually remember that, you know, the true horizontal openness is much more than just front hall. So in case of 4G or LTE, we are looking at the X2, which is interoperable, right? So, you know, the one which I marked with red, and it has to be interoperable with other vendors. So on the surface, you may say like, oh, well, X2 is defined by 3GPP. So should this not be open? Like, you know, what happened? The problem is, in theory, yes, that's true. In practice, well, most big vendors, they used proprietary message contents, right, that were not defined by 3GPP, and this caused many issues. So, you know, some people who probably remember the early days of 4G, you know, and this is when we also had small cells making a lot of noise. And they might actually remember that most of the big vendors, and there used to be a lot more big vendors back in 2008, 2009, 2010, they didn't really implement the X2. You know, X2 was implemented much later, right? And when it was implemented, it was just not interoperable at all. So yes, so when we are talking about the horizontal openness, right, it has to be open X2 as well. And then we also have the vertical openness, which is also known as virtualization or compute disaggregation. And of course, you can have Open RAN without virtualization, but it just won't scale. And frankly, it doesn't really make much sense. So, you buying like a proprietary hardware still, right, and putting it like under the tower site and things like that. We have to transition to virtualization sooner or later, right? So, and it's great to see actually quite a few players are taking a lead in this area, not just the newer ones, which are more agile and much more flexible, but even the traditional big players. So we are sort of like three simple definitions. So going back to this picture again, right, and this one was more for 2G, 3G, and 4G. What happens with 5G is we split the BBU into the distributed unit and the central unit, right? So DU and CU. And in practice, especially for the initial implementation, this may all be just a logical separation. So, it might still be on sort of like the same hardware, same server, and it might still be in a distributed RAN fashion, situated at the bottom of the tower. But of course, we are still in the initial phases. Things are going to actually change sooner or later. So again, when we talk about the RAN splits, right? Because when we talk about DU and CU, we have different types of splits. And what I try to do is I try to actually summarize a lot of these splits here. Um, so, for 4G, you have even for 2G and 3G, right? You basically have this traditional split 8 kind of approach. And of course, this split 8 only came because of 5G. Before 5G, you didn't really have split 8 and things like that. So we had this standard split, right, where we had the BBU, right, and we had the RU or the RRU. This is like the pictures which you saw earlier, right, which is the RRU on the top and the BBU at the bottom. And you can have the same kind of split 8 for 5G, but it just doesn't make sense because the amount of data that's required on the in the front haul is just too high. So we have all these different splits, right? So this is the one which was proposed by 3GPP, and this is what a lot of vendors and operators use today. So the split two, so the DU, basically the DU RU, or we also call it RDU. They contain of from RF to RLC, and then you have the CU, which is basically PDCP, SDAP, RRC. Then you have the split 7.2, which is the one which ORAN Alliance is basically making it popular. And this is also gaining momentum with other vendors because it actually makes so much more sense. The amount of data that's required on this interface is far lower than what amount of data is required here. And then you have a combination of the split 2 and split 7.2, right? And this is going to become this is the one going to become popular with especially with when the more networks become ORAN compliant. So this is how we see people moving actually in the direction in the future. And just to give an idea, so this is just an example which I picked up, and I can't remember, it probably might be from one of those initial SK Telecom presentations, but it's just showing that like in practice how would the networks really look like. So you have the 4G, it remains as it is, right? But when we talk about 5G, you might have this ORAN based split architecture. You might in some cases still have the split 8, but you might also have small cells. Well, basically you will have just a split 2 for small cells. I was actually going to include this slide from Small Cell Forum, but I forgot, which basically Small Cell Forum shows all the different kind of splits that are possible, right? So they call it like the two box and the three box, or the three splits, two splits, kind of different architectures and what different combinations you can have. So there are a lot of things, and at the end of this presentation there are some links, so you can actually go back and listen to some of the other presentations and the webinars, everything which we did, and you will find a lot more information in them. Right. So coming back to our, the horizontal openness for 5G, right? So we saw the decomposition. And now basically when we talk about the open interfaces, it's not just the front haul, but we are also looking at the F1, and not just the F1, right? So basically even the XN interface, so which is equivalent to the X2 interface in case of 5G, right? And then of course, even with 5G, you can have the CU and DU virtualized, so software can be running on a commercial off the shelf or COT server rather than custom built hardware. So, in summary, when we move from an open RAN to an open RAN deployment model, we can then have software from different vendors. So, if I show, so like, these are software, so DU software from different vendors, right? They're running on the COT servers. You have the CU software, which could be from a vendor, and then you might not like that vendor, so you might replace their software. It should all be like a plug and play kind of approach. And are we there yet? I will discuss it at the end whether we are there yet or not. But the most important thing initially, which sort of everyone is focusing on, is basically the radio units, right? So the radio units, you can actually have any vendor who is making a radio unit which is compliant to, let's say, the ORAN 7.2 specs. They can bring in their radio unit, and you should be able to do a plug and play. Frankly, easier said than done, right? Because we are not there yet. But yeah, but in theory, this is what Open RAN basically enables. So an operator can do mix and match based on what their requirements are and whatever works for them. So, some operator, especially in rural areas, might be actually looking for a cheaper version of the hardware, right? Or a smaller COT server, right? But in a dense area, you probably need the best hardware, the best COT server you can get. So all these requirements can basically change from location to location and all kinds of things. And this is what Open RAN will do. It will basically enable plug and play of different components within the mobile network. So if we look at the whole the approach, right? And you would always have people, especially the big vendors, arguing that, well, virtualization is not really needed, and which is really true. Actually, you don't need virtualization, as I mentioned earlier, but it does make sense. Going forward, you can't keep on having customized hardware, for each particular scenario, or for each upgrade you need to get like a new kind of hardware. So what we define at a very high level is, right, you have the virtual RAN, but not all virtual RAN is open RAN, right? Because you can have a VRAN where the interfaces are not open. So Open RAN, you can say, is a subset of a VRAN, and so the baseband, you can say, is split into the DU and CU, and you have the open interfaces, right, between the CU and the DU, but a lot more as we looked at. And then you have within Open RAN, right, you have the two groups. So which is one of them is the Open RAN without any space, which is the one from Telecom Infra Project, or TIP. Um, so Open RAN group from TIP basically is supporting the interoperability and all kinds of things, but they are supporting for all generations. So 2G, 3G, 4G, 5G, right? Whereas ORAN Alliance is basically very much focused on 4G and 5G. But even if you actually look at their the specifications, is very much towards 5G, right? But then 4G is there as well. So a lot of different groups and a lot of different terminology. Sometimes people get a bit confused. So I always put this slide just so that everyone is on the same level. And this is, so this is the high level architecture for a 4G, 5G network as defined by ORAN Alliance. So I'm sure you have seen a lot of different architectures from ORAN Alliance. And one of the things I actually always complain to them about is they don't really have consistency between their diagrams. With 3GPP, everything is exactly the same. You pick up any specification, what it means. With them, their architecture diagram has changed. It used to be much more complex. I haven't included it in this one, right? And they use sometimes different terminologies, different coloring schemes. So I've sort of internally in parallel wireless, we have sort of normalized all the colors. So we try and use for the ORAN defined interfaces the gray, the 3GPP defined interfaces is the black one, and anything that is out of scope for ORAN is basically the orange line. So we tried and internally create a consistency. And again, I'm not going to go in too much detail in actually this particular presentation, but the good news is that uh, I'm in process of making some introductory videos on the whole ORAN thing. Um, so it's all available on Parallel Wireless YouTube channel. At the end of this presentation, and this presentation will hopefully be shared with you guys. So there is a link to all the the playlists and things like that. You can just click on that, and as I always tell people, whenever you can't sleep, right, whenever you are bored, whenever you are depressed, you can listen to one of these presentations. It gives you nice sleep, and then you can continue doing it the same next day. If you run out of if you understand everything and run out of things, just let me know. I'll prepare some new one. So yeah, so in very simple terms, right, when we talk about the O cloud, as you can see, you can think of O cloud as a COT server on which virtualized ORAN network functions can run. The ORU, again, anything that ORAN Alliance defines, they put an O dash before the name. So the ORU is the split 7.2 radio, and it contains the lo-fi, right, along with the radio unit, as we saw earlier. So then we have the near real-time RAN intelligent controller, or the near RTRIC, so this one. And the near RTRIC is defined as the logical function that enables near real-time control and optimization of RAN elements and resources via a fine-grained data collection and actions over the E2 interface. Then you have the service management and orchestration and the SMO framework, and the non-RTRIC is the part of the SMO. So SMO is so in a network there can be many different management domains, right? So you have the RAN management, the core management, the transport management. You have the end-to-end slicing management, right? And a lot more things. So the SMO is responsible for RAN domain management, right? So SMO is just dedicated for the RAN. And then, of course, you have the non-RTRIC, which is defined as the logical function within SMO that drives the content carried across the A1 interface. So this is the A1 interface. So, important to see that you have the O1 interface, which connects from the SMO to the whole virtual functions, but the A1 interface connects from non-RTRIC to the near RTRIC. And again, as I said, like there are a lot of things to actually unpack in this one. If you want to learn more, you are more than welcome to go and listen to the more detailed architecture on the our YouTube channel. And then, of course, you have the uh, the RFs, which basically run on the non-RTRIC, right? So one of the main things is a lot of advanced functionality which we would have in a network is basically created like an app. So you have the near RTRIC, and there are apps which run on the near RTRIC. So near RTRIC is more of a framework, and your X app will have intelligence, right? And people always ask me like, what are X apps and what are R apps? Why X and why R? And I couldn't find a convincing answer, so I made an answer, right? And my answer is basically, well, X stands for any. So anything which you really want to do with with the more like from the RAN functionality point of view, it's all X apps. So initially we are looking at SON kind of X apps, but SON isn't the only thing. You can have RRM functionality as X app. You can have some policy functionality as accepts. And if you're collecting information, you can actually create a lot of interesting things. And this is what will become a differentiator. So going forward, you will have small companies, right? And India is basically a hotbed, right? Because you have so many companies, you have so much software expertise. Some company will make an XApp and they are specialized in like one particular XApp, which is very niche. So they are experts. Okay. And then, another company basically will have another kind of XApp and they are experts in that. And an operator can actually go and say like, hey, can we basically use your XApp to do this in our network, those kind of things. And RApps, and again, what does R stand for? So because I just mentioned that the SMO is basically just for the RAN domain. So R, according to me, is for the RAN. Just saying that this is the more for the R RAN app kind of thing. So yes, we will see a lot of new players, a lot of niche players in this. And of course, you will have big players which will provide generic XApps and RApps. And with the way things always go, right? Somebody might create an XApp or an RApp which is like really good, and some big player might buy them out. So all kinds of possibilities in future, just have to be prepared. And if I quickly jump onto like, because you saw the whole ORAN architecture, this is just to just drill down one level in detail. Like, if you talk about 5G, and you have DUs and CUs, you also have this interface called the E2 interface, which is again the ORAN defined interface. And this is the interface on which a lot of data is collected actually from any of the E2 nodes. So DUs, CUs, they are all called E2 nodes. So the near RTRIC will actually collect a lot of this information, all kinds of information with the E2 nodes and pass a lot of these things to the non-RTRIC, which might decide on, because it's non-real time, it will decide on like, at a high level, what kind of a policy do you want? Whereas near real time is more near real time, right? So the only real time things is the ones which are like a layer 1 and layer 2. Above layer 2 is really near real time. So yeah, and this is if you talk about 4G, you have the BBU or the OE node B, which is how the ORAN Alliance defines it, right? Like in 5G, they will provide a much more detailed architecture, but in 4G, it would be always like, oh, OE node B. So just at a high level, right? So this is the thing which is like, okay, I had to think about it, right? I don't want anybody to come back and say like, oh no, we don't agree with you. So what about the maturity, right, in terms of standardization and product availability? So when we talk about the open 2G 3G networks, so they are supported by TIP, but they are not supported by the ORAN Alliance, right? uh, and they are being deployed today. I'm going to show you just like a very brief slide about PW, parallel wireless, and I'll show you like, some of these networks which we have deployed. But when we talk about the 5G, 4G and 5G networks, so they're supported by TIP and by the ORAN Alliance. And in fact, in TIP, the way it works is a lot of interfaces are now used by TIP, but they are defined by the ORAN Alliance. So you have to really be a member of both of them if you want to take advantage of TIP. But you can, of course, be just a member of ORAN Alliance, if you're just interested in the interfaces and architecture and things like that. Then we have the open radios, right? And this is what I alluded to earlier. So yes, you have the one supported by TIP, mostly, just the RRU part, which have been deployed in many different networks. But now, especially for 5G, they are supporting the ORAN Alliance. So with the split 7.2 radios. And with the split 7.2, really what you have is the 44R, which is available today, right? The 44R radios. And the more advanced radios are under development. But that doesn't mean if you look at some of the announcements, so some of the big vendors, hardware vendors, they have more advanced radios, but they are not available for general public. So they might be deploying it. It might be ORAN compliant. It might be split 7.2, but they are not available to other companies, right? So one of the questions which we always wonder is like, look, you know what? You say you are an Open RAN company, and our operator deploys everything from a single vendor, right? And they say like, well, we are an open network. But if you do not deploy it from multiple vendors, right? Can you really say is your network open? And you can argue with both the ways, right? Whether it's open, it's not open, right? The open front haul, right, is sort of mature, right? Open interfaces still being standardized. So you have some interfaces which have been standardized, some interfaces are still in the initial stages. Compute disaggregation has been around for a long time, right? Since the core network, since the 4G days. So it's very mature. The control plane disaggregation, right, and the SMO. So RIC and SMO, again, I think they are still they still have some way to go. And RIC is probably, especially the near RT RIC, is a lot more mature than the non RT RIC and the SMO. So yes, you still have a long way to go. If you think about the ecosystem maturity, and we have to think that it's like a good thing, right? Because it still has we all have a lot of opportunities. So any of the companies, some people might be thinking about startups, right? Or somebody is working in startups and they might have a product. So yes, there is a lot of opportunity. Surprisingly, as a company we still get so many requirements on 2G. And this is a completely separate discussion. I can talk about this 3G shutdowns and 2G shutdowns kind of thing. But in terms of the ecosystem maturity, right? So I don't, generally you would only hear like few companies being mentioned, and it's always good, right? That parallel wireless is mentioned a lot of times, and of course, Rakuten is like mentioned a lot of times. But the ecosystem is actually quite active, right? And I just wanted to put this picture out from ABI research. But these are the ones which are very active. But these are not all the companies. So if you look at uh, Telecom Infra Project or Oran Alliance, they all have over 200-300 members. It's like a really, really big ecosystem. But because this is what you hear about more of the time. So again, this is the sort of like the ecosystem. So system integrators, the software suppliers, the radio unit hardware ones, CUDU hardware, right? So more like COT servers, but they might have accelerators, the secure virtualization platform suppliers, the chipset suppliers. So it's a big ecosystem, and there are loads and loads of players. So as I said, right, this is just a select few, right? So if your company is not in here and you are an Open RAN or an ORAN player, please don't get upset with me. This is just like a very small snippet of the companies. um, so yeah, so just very briefly talking about us, that our company, before I conclude. So yes, we have been around doing Open RAN for a very long time, and we might have just changed the terms. Sometimes Open vRAN, sometimes just vRAN, and I think now because the whole industry is standardized to Open RAN or vRAN, so we just use the Open RAN, and we have deployed in a lot of different networks. So these are the publicly announced networks. A lot of networks we are not uh, publicly announced, right? Because we work through third parties or other integrators or satellite providers, all kind of things. So yeah, we have deployed for these different scenarios, which I actually listed here, right? Whether it's modernization, because there are still a lot of 2G networks which have really, really old hardware. Those if you have been working in 2G and 3G, even the Node B or the BTS used to be like a big cupboard kind of thing. So yeah, so they still have those hardware which is basically consuming a lot of energy. And when we do a modernization, we replace that one by like a just a simple COT server running multiple generations, and it just saves so much power, really. So it makes so much more sense. So you have the modernization, you have the some operators deploying to improve the coverage, some wanting to deploy capacity because they have a lot of users, some for 5G readiness. We are also into public safety, so we have one which is the ESN in UK, but we of course have a lot of other military or the public safety networks which we are working on. But of course, you cannot mention the names here. And just in case if you're confused what we really do, so yes, we do software for the DU, the CUs, right? And in some of the things we work with partners for the remote radio heads, for the rigs, we work with partners. So yes, our strength is software, for all generations, right? 2G, 3G, 4G, and 5G. So that's just briefly yes. And as I said, right, you have if you want to dig deeper into this particular topic. So, we have Open RAN introduction series, which we did last year, and we didn't realize how popular it would become. So I think the one which is like the top viewed video in this series is something over 40,000 times, so 40,000 views. And again, the ORAN ones I'm working on now, as and when I get a time. There are 6 videos, I think, already there. We also have a Bright Talk channel where we cover like a lot of topics. And again, this is more from education point of view. We think if we basically educate the industry and we are sort of all on the same level, then it's easier to basically have discussions. So, most of this stuff is vendor neutral. Um, and that's sort of about it from me. Hopefully I didn't take too much time.
Yeah, thank you, Jahid, for very, very informative and wonderful session you took. Now maybe you can open the floor for a few minutes for any question which participants may have. So we have more than 350 participants as of now. So if you have any question, either you can write in the chat box, or if you want to speak, just raise hand. I'll kind of open mic for you. So in the meantime, a question comes. I have one question. In terms of numbers, that how many operators are actually investing or have invested into Open RAN, and can we compare with kind of the other kind of the RAN network which you have today with the Open RAN in terms of number? Do you have some idea about that?
Yeah, so number is basically going to be difficult. So if I just think on top of my head, right? So we are in over 50 networks. So just us, and all our deployments are actually Open RAN, but it won't be a complete network. So this is just us, right? So there are a lot of networks actually. Some very big operator groups have actually announced. So, if you see the Open RAN MOU, for example, which was signed, so you had Vodafone, you had Telefonica, you had Telecom Italia group. And I'm just trying to think who else was there. There is some kind of a MOU which Middle Eastern and operators have signed. So you have STC, you have MTN. You have Orange. Of course, I shouldn't forget Orange. Be working very actively with them. So there are lots of groups which have announced. So if you look at the likes of Orange, for example, they have clearly said that after 2025, any vendor that's selling anything to them has to be ORAN compliant, right? And other operators like I think Vodafone and Telefonica, they have said similar things. So Vodafone has a very big ambition of replacing a lot of European the network. So the new ones, so every time they are putting in a new base station, right, or a new site for 5G or whatever, they want it to be ORAN compliant. So there have been a lot of announcements like this. So it's going on, right? As I said, there is some work to be done, especially in terms of the maturity. We will get there sooner or later.
Yeah, thank you. So there is one question by one of the participants, that is there any standard on Open RAN security?
Yeah, so for the security, there isn't something available today. So there is in ORAN Alliance, there is a new security focus group which have been formed, I think probably 6 months ago, and they are going to produce some documents on that. I don't think they have already produced one, but I know it has been under discussion. So yes, you will have some more information coming, but you have to remember with security, it's all recommendations. You will never have any standards body say like, oh, do this, right? they will basically give you a lot of recommendations what operators should do. In the end, they have to be the one implementing it. But yes, a lot of stuff is coming on Open RAN security.
Yeah, thank you. So one more, let us take one more question. And other questions are related to perhaps subsequent sessions, so we'll take at that point of time. The question is that other than, and what are different challenges to Open RAN, other than those challenges which are related to integration from different vendors?
Yeah, so I think the one which basically everyone talks about most is basically the integration one. But one of the challenges which is there, right? And I should have actually talked about it. So let's say like companies like us, when small companies, right? When we want to deploy 5G, because 5G today you have the non-standalone networks. In the non-standalone, you still have 4G generally from a big incumbent vendor. And because the interfaces are not necessarily open, you cannot take a 5G radio and say like, oh, can you put it with the 4G radio, right? Because it's a non-standalone. So a lot of Open RAN vendors for 5G are actually waiting for standalone networks, standalone 5G networks, because this is going to be a big opportunity. So yes, this is a challenge. And even when the operator basically convinces the big vendor to basically say like, oh, work with this small vendor for the 5G new radio part, there are so many challenges. It just doesn't work, out of the box. That's what I can say.
Yeah, thank you so much for answering questions. So I also request you that there are few more questions on the chat box. If you can just reply there, so that in the interest of time, I start the second session.
Okay, I'll have a look. Yeah, I'll have a look.
Thank you very much for this wonderful session. And I request if you can continue in this particular webinar, so that any more questions we are able to answer, which may come at the fag end of this particular event. So going forward, now we have with us Mr. Hiren Joshi. He is head of operation from Rakuten Mobile Inc. Japan, and I have already introduced him. So the second session is about the Open RAN experience. So as you all must be knowing that Rakuten is an operator, rather they offer platform even to other operators, wherein they are promoting Open RAN and cloud infrastructure architecture. So now, without taking much time, I hand over to Mr. Hiren Joshi. So over to you, Mr. Hiren. I'll just unshare and you can share it, sir.
Very good morning, all. Give me a minute more to just share my presentation.
Yeah.
I'm not sure, but the link is still not enabled. Sharing, I don't know.
Just a moment. So you are already a presenter, sir. So on the top, just after the mic button.
Yeah. Now it is enabled. Now I can see that. Yeah.
Okay.
Maybe it took a while. Sorry, my security policies are taking a little more time.
No issue.
I didn't realize.
So in case you face problem, I have your PPT which you shared a day before. If that is the same, I can present from here.
Let me reshare it, because I think this asks me to reboot my Teams, which may take a little more time.
Okay.
So give me a moment. Maybe it'll be faster if I can.
Or you can use browser and using the link you try login again. Parallelly, you can do that. And there, if you're able to share.
Yeah, I think now it's I can see this is coming up.
Okay.
It's just the internal firewalls are taking some more time, a lot of permission. So
Many times, yeah. We can see your PPT now.
okay, you can see my PPT?
Yes, yes. You can
Oh,
go.
okay. Okay, that's great.
Yes,
Okay, so it's now full mode visible. Okay, great. So thank you so much, and sorry for that delay. My sincere thanks to National Telecommunication Institute for Policy Research, Innovation and Training, DoD Government of India, for giving me this opportunity to express our experience and our views on Open RAN. It's really my privilege. Thanks to all the eminent speakers earlier, and Zahid, thanks a lot for the great presentation. A lot of complex topics you really presented so great in a very easy format. So really appreciate. Hope I could do similar justice with my presentation as well. Let me start with a brief introduction. Maybe I can skip in interest of time. It's just I've been working with Rakuten Mobile. We have set up this network in Japan, and now doing a similar thing for Germany for one of the operators. I've got a substantial experience through some of the Indian operators, which helps me understand your perspective a little better. Let me skip this, just we are running out of the time. A quick 30-second brief on my company. So I think most of you would know Rakuten as one of the mobile network operators, but to give the larger perspective, so we are the conglomerate of more than 70 businesses across the worldwide, with more than $208 billion of volume revenue, and now venturing into the telecom side since last 3 years. This is the agenda I plan to cover. Some of the brief on the Open RAN, maybe we can save some time, as Zaid has already explained a lot of things. And then wise would we do directly jump into the Rakuten mobile networks, what are the solutions which we've used in our entire ecosystem, how we managed to do this rollout, what are the benefits, and then how it's our overall lifecycle experience, and how do we see this going from here. And then maybe we can spend some time on Q&A. So this is the peeling of the layers. So like Zahid was explaining, the radio access side, which is one of the most complex place for the mobile networks. The earlier versions had all proprietary hardwares and the proprietary interfaces, which prohibited very limited exposure outside their own domains. To connect core with RAN, and within RAN also the baseband unit, the digital framework with the radio unit on the front haul. But for the reasons like Zaid was mentioning, so I'll skip. The industry realized the need to, number one, to move to the commercial off-the-shelf kind of hardware, the COTS hardwares, to make the hardware and the software layers independent, which gives a lot more flexibility to the operators to maneuver and manage their capacity, scalings, and a lot of other automations as well. So the initial was to move away to make the hardware and the software as the independent entities. Further, the second level of disaggregation happened when the DU and the CUs, which were separated out, the option 2, option 3, which were just mentioned by Zaid there, which the main incentive here was the real-time applications and the acceleration adaptation layers. So the DU, which is more closer to the radio, that needs to be made a lot more intelligent, faster to work with all accelerated techniques. And this was the real-time demand on the 5G as well. So the CU and the DU had to be separated out. And then finally, it went on further. Even in the CU side, the user plane and the control plane started segregating. So with this disaggregation of all these network entities, separation of hardware and the software, the idea was to have the open interfaces across all these network elements, and that's where the Open RAN came into the picture. Because not only you want to disaggregate, but you need a lot more flexibility in terms of vendors, in terms of customization, and meeting your own needs. A lot of it we would talk in the further slides as well. Just quick on the general industry adaptation, which we saw for the macro kind of scenario, where on the interface, most of the people adopting to 7-2, where they just split the physical layer to make the radio unit side, which is hanging on the towers, as dumb as possible, so that you don't need to do too many things, and most of the things carried on the digital side, which can be controlled remotely, and essentially the hardware box on the tower becomes just a kind of a replaceable FRU. Also, there were adaptations across the small cell forums and the Open RAN LANs. I wouldn't speak more because Zaid already mentioned about it, where it seems that while 7.2 becomes the adaptation layer on the radio side, option 6 from the small cell forums, the network function API to connect DU and the PHY layer. And similarly, option 2 being adopted between the VCU and the VDU. So this seems to be a more general kind of an adaptation on the open architecture, and this is how we see the different vendors or different developers picking up the different segments in these interfaces. However, there's a lot of variation as well. So I'll straight away jump into what we did at Rakuten. Just to put it in a very simplified format, we got all the interfaces mentioned in the previous slide completely open to have the multi-vendor operability. Most of these vendors work closely with us to define as per our specifications and standards, not to violate 3GPP, but it helped us to define a lot of service layers, a lot of management layer interfaces, and so on. Similarly, we had the DU, which was open for the multi-vendor operability, and which we virtualized as well. That's the virtualization layer I was talking about. And we got this entire virtualized architecture on a Kubernetes framework so that we can deploy in form of the containers. So that's in brief how our approach has been. These are some of the different combinations of the solutions. Since we were in a very unexplored market, we got an opportunity to build kind of the product along with our vendors. So the three major type of implementations, what I explained, which translates into different types of products. So for example, the type 1, where we got the CU and the DU as two different network containerized elements on our cloud platform, whereas the RF unit at the remote, and we got something called RIU. So this is more like a multiplexer, and some of the common functions like providing GPS to the site, those can be put in the RIU. So while the intelligence, we could do the left shifting for the remote access, on the right side, we tried to do some kind of a efficient implementation to cover more RF units on a given place, which also helps us to have the higher span, more number of RF units using the same GPS and a minimum hardware at the tower on the site. The second implementation is where we shifted the DU towards the RF, and this is quite understandable. As I was explaining in the previous slide, the DU is where the real-time applications become more dominant, and you need more hardware, a lot more specialized hardware for the accelerated handling of real-time applications, and which is why the DU had to be shifted on the right side for mainly 5G and some of the 4G applications as well. And last one is the implementation, more like a small cell implementation, where you have a very simple DRAM kind of solution, where you have distributed RF units with a completely embedded DU in there, and you have the CU very remotely far away in the data center in a containerized platform. So type 3 mostly goes for the scenarios like small cells, femto, and we have the range of products on those one. So these are the three prime solutions in which most of our products are have been designed, and still the new products keep evolving on the same lines. Before I could explain other things, it's also important to understand our ecosystem, which supports to the Open RAN and the vRAN scenarios for us. The key comes from the cloud layer, where we have our own platform, where we have deployed the Kubernetes-based container system. Some of them were also in the OpenStack, but by and large, the major deployment goes on the Kubernetes layer with the cloud orchestration, which means the network functions, most of them, whether it is RAN or core or across the network, lie as a software entity on the top of it, which makes it a kind of a uniform software-defined network kind of architecture. It gives us great flexibility for interconnections, because everything is just software and configuration. It gives a great flexibility for auto healing. So in today's days, if something goes wrong, you have to physically go and replace the hardware. That's unimaginable in this era. So everything is a software, auto scaling, auto healing. You just the containers get recreated, and then it starts from the fresh. The software cycle becomes very easy the moment you want to upgrade your softwares. It's just creating one new, and then the old one dies out, and the rollout. The typical benefit of the cloudified network. So diagnosis, troubleshooting, and auto scaling. Auto scaling is also very easier. So to redeploy or to scale up becomes very simple, because it's again another software. You just keep deploying on a common platform. And the third layer is also very critical, which is the orchestration layer, because to manage all these software elements, the virtualized elements, interconnection and the topology, and the features which you mentioned, the auto healing, auto scaling, and the auto redeployments, that cannot be achieved manually. So you have a very strong, we have a very strong OSS orchestration layer embedded with a lot of analytics and AI/ML for the decision making. So this Open RAN architecture, along with this open hardware software interfaces and the COTS-based design, a cloud native core, the automation and the AIOps, the intelligence operations, with a cloud native telco platform. This is what our ecosystem, which gives the overall strength to our network. Why this was important to know is that it may be misguiding to see the outcome, which I'll show in the next slide, as a sole outcome of the Open RAN, but it's this ecosystem complementing with the Open RAN adaptation, which gives the real strength to us. So let me move to quickly how we did the rollout. So we were a greenfield operator, and naturally we had to be very strategic in our deployment, working on a very sensitive market. So we, as I mentioned, we had the containerized platform already deployed. We had to partner with a lot of vendors to make this happen. We had to also partner with the other mobile network operator in Japan to cover on those areas where we still going into the rollout. And then we had the very heavy acceleration with help of the zero touch infrastructure automation and the solution which was developed along with our partners very closely. So we are going at a speed of we almost covered 90% of the Japan coverage, and that's almost in last 2 years on a rough scale. And what we see as the outcome is that we are still able to manage the availability quite well. In fact, for the matured phase 1 network, we are more than 99.95. But the overall, with the deployment still under progress, a little bit modulates our availability. The accessibility, retainability, we are doing phenomenally good. And let me also talk about the field performances which we have observed with this deployment. So fairly well 4G, 100 Mbps on field. We are able to demonstrate the single user peak throughput levels. Same way for the 5G, we could show up to 1.8 Gbps with 400 megahertz in a millimeter wave. In sub-6 space with 100 megahertz, we could demonstrate up to 1.2 Gbps. The latency levels, this has been very tricky because you can improve the latency by compromising something, but at our deployment level, without any other compromise, we could get less than 35 millisecond of latency for 4G, and same way for 25 millisecond at the sub-6 5G, and even less than 18 millisecond for 5G. We have more products in pipeline, and we are very optimistic. We still have huge opportunity from our experience to improve on the latency as well to support URLNC applications. Of course, from the capacity also, just to give the note there, we could also demonstrate more than 700 RRC connected users per sector. Apart from those field observations, some of the key benefits which I would like to demonstrate is one of them is the elasticity, the scaling which I was referring to. So deploying more eNodeBs on need-based for, let's say, for the Olympics, or even for the rollout case, this became very easier for us because we had a common platform, and just deploying new site was more of an acquisition, and just put the RF unit there, the radio units, and you don't need even the digital boxes there. So you just need to have the power supply system and a connectivity, and then the permissions, and then you put the radio hardware there. On the back end, everything is automated, and the scaling is like almost automated, touchless. Very easily, you can achieve 150 sites for a given instance deployment at the same time. So this elasticity and the platform was the very critical key for us in the fast, efficient, and the quality network rollout. This is also one more interesting thing. So while we work for the Open RAN, we get a lot more flexibility to design our products in our own way. And this is one of the classic case. Like Zaid was also mentioning, and most of us would already know, the big pain we had while connecting the radio unit with the antenna. If you have the feeder cables, they have a lot of losses. Not just losses, but they put so much stress on the OPEX. Most of the time in rainy seasons or any catastrophic conditions, these are the pieces, the interlocking connectors and elements which get damaged. Not only you have the coverage lost due to the lossy part, but it also adds to a lot of other maintenance work. So in our case, we had the antenna directly connected to our radio units. And the radio units, as I mentioned in the previous slide, is just a bare bone PHY layer. So it doesn't have too many intelligence onto it. So it's a very simple, small hardware connecting directly to the antenna, which to our estimation, we could save a lot of losses. We could also design the radio units with power levels of 160 watts, which is not very usual. Most of the cases, up to 80 watts are known, but 160 is not very common. And we got far more reach. On a very conservative scale, at least 30% of the coverage we see better than our traditional operators, and which means the 30% less sites as well. Another some of the benefits, which in the interest of time, I thought we'll not be able to go in detail, but just to apprise you. So the cell site deployment for us is 4 minutes to 8.5 minutes due to the faster orchestration layer, which I already mentioned. Any new feature deployment. So those who have worked in the traditional days, any new feature, you ask the vendors, and then vendor develops, and then they give the software, and then the upgrade needs to be done at a different layer, EMS layer, and then the eNode B, and then there's a whole lot of process. For us, this is just a 6 days, because the CI/CD pipeline immediately helps to not only capture, develop, unitary testing, interoperability testing, and the faster deployment, and which happens through the deployment framework. So it's considerably faster. So which is why we are able to do a lot of changes. And this is very vital for a network which is in a growth state. Resilience. Also, as we mentioned, the network availability, we are targeting for 99.99999%. We are already at 99.95 for the matured segment of the network, and overall 99.885 around, and it's improving as the time goes by. Now, this reason is because if you compare with the traditional operators, what are the areas why you have failures? What are the areas where you have unavailability? Compare it with what we have been able to productize and deploy. There's no failure point. Most of the things you have faster healing or auto scaling, or you have the robust very dumb thing on the field where you don't have too many failure points. The last one, this also puts us in a good shape to require less number of resources and save our OPEX. This is just a guesstimation from our side. The engineer to subscriber ratio, we are substantially lower compared to any other traditional operators. And then this is what we see, the overall experience across the life cycle at a planning stage, build stage, and the operation stage. At the planning stage, we see the product planning, as per the network requirements. So the operators know it very well what challenges we face, what solution we need versus what is available. You go with a set of vendors, and the vendors have their standardized solution, which they probably built to support the networks globally to make it omni-adaptive, which gives operator much lesser flexibility to design their network and deploy them. So we got a very good flexibility in this planning, because product planning was very easy. We just opened out on our interfaces and worked with the vendor partner ecosystem. Some of the challenges faced and the dilemma to choose the right solution, because it's easier when things are done, but at the planning stage, this was very, very key. Any strategic misalignment could have dethroned us very badly. And of course, the risk mitigation to bring new, very fresh ecosystem, which there's no precedence. Still, not too many operators are full-fledged into it. But the previous presentation gives us hope, a lot more operators adopting now. So that's really great. At the build stage, the deployment was very faster, as I already showed on the numbers. The flexibility of deployment to deploy, undeploy, redeploy, to reduce the speed of it based on the project plan. The flexibility is a very, very big advantage. And finally, most important, at least 40% capex reduction, considering the overall traditional operators, comparing ourselves with them. Of course, there were challenges related to building the quality acceptance standard, because the market is extremely sensitive. One place where the negative tweets and those KPIs go as fast as your real-time KPIs, nearly at the same speed. It's such a sensitive market. So making sure the quality acceptance standards, all the testings, and this was a very big challenge. There were not too many precedents out here, but we are happy we could manage this challenge as well. Most importantly, at the operation stage, we see a very high resiliency and availability due to a lot of flexibility. Most importantly, due to the data points available for analysis, the 5i analysis or applying the Six Sigma methodologies to know where exactly we are failing, and then opportunity to overcome that. I think that was a very, very big breakthrough in achieving the very high resilience and availability. The scalability I already talked about, and of course, very steep reduction in the OPEX. And we see a lot more opportunity. So as the products get more and more matured and our new products get in the line, we expect even higher efficiency here. Not to say everything was great from the day one, because the initial effort in reaching to the product maturity was really, really a big challenge to us, because software, the bugs and new feature requirements. So this was a big challenge, but the implementation cycle is so fast that you can turn around the situation very fast. Finally, this is what my personal thoughts, considering my experiences working with operator, working with Rakuten. I think the OpenN is a big remedy to catch up with many challenges which the operators are facing. We are expecting a lot of complex deployment requirements, which will come in a very near future. The 5G will have to go for deployment very fast. So how do we meet these requirements with the only few standardized proprietary solutions? You have to open out so that there's a higher level of innovation. The speed of innovation and the speed of mass deployment will require multiple entrants in the space, not just few key global players who basically govern the market. We need a lot more players with more appetite for innovation and meeting the global demand. And OpenRAN gives them a lot more welcoming entry. More so, 5G and IoT, as we all know, this is still in a very, very initial stage, and we have miles and miles to go, which means things are going to evolve. And if things are going to evolve, how do we catch up with the speed of evolution? The speed of deployment will require a lot more openness in the interoperability to have multiple vendors, developers, and gain the momentum. Finally, as a country, the unique advantage we get is by the virtue of being the global hub for the software development industry. This gives us a very, very big opportunity to tap more industry, more leverage for the economy, because you become less and less dependent on the proprietary hardware solutions. So with this, I'd like to just apprise everyone on the recognition we got from the world around, and which is really encouraging to us to work further on our path and help the telecom industry go through a complete shift and help the industry to grow. I would like to stop here and pause for any kind of questions.
Yeah, thank you, Hiren, for wonderful presentation and also telling us about how Rakuten has deployed a cloud kind of a network for mobile, and also your network is not a normal network, but it's a platform. You explained that you're using kind of a containerized applications for all the component of mobile network, and also you have Mano kind of environment wherein in an agile way you are able to deploy your network whenever required. So I have a small question that I mean, was there a case that any point of time you ran into operational challenges because of the new Open RAN technology which you are deploying, and whether that the way you have deployed, like whether the Mano and a containerized way of deploying that application help you in that directions?
Yeah, it helps me every day, because the fastest way operationally to manage is just recreate those containers. So that's the biggest flexibility I see because of the Mano architecture. Because in open interfaces are, until the product matures, definitely prone to the bugs and the interoperability issues, which needs to be fixed. But for operations, the things are live. You need solution right now. So for us, that's the reason why I chose to explain the complete ecosystem. It's not just the Open RAN which gives us the strength, it's the ecosystem which complements.
Yeah, thank you. And there are some questions in the chat box, but before that, our DDG Sunil sir has raised the hand. Sir, if you like to interact with or ask any question.
Yeah, thanks, Hiran, for this wonderful session that you have taken. In fact, actually, we have extensively listened to your CEO also, who is a very popular figure in India. So in his sessions with the Indian media, he has told about three aspects which I would like to just ask you. One is that Rakuten's network is EMS free. It has been told. So what is special about that? That is one aspect. Second aspect is that instead of Volte native dialer, it seems Rakuten has implemented an OTT application called Rakuten Link app. So that is the second aspect. And third one, just last my doubt regarding this RCP platform that we have built. Is it a core network with all network functions implemented on top of that, or what else is that? Can you just in 1 minute briefly tell about it?
Yeah, sure. So let me go one by one. So the first one, let me start from the reverse. So the RCP, Rakuten communication platform, it's basically a Kubernetes platform where you can host different VNFs on the top of it. So it does not have the core as a platform, but the core VNFs, the network functions, are being deployed as a container in that RCP. RCP basically gives the infrastructure platform, and it also gives the orchestration platform onto how do you onboard a particular application. Now, this application could be RAN, CU, or it could be a IMS network element or anything else. So you host it in our orchestration, and that orchestrator deploys it on the platform. So the rest is just mounting onto the applications on the RCP orchestration layer. Your second question on the link. So yeah, that's true. So what we felt is that the present ecosystem on the roaming in terms of the international dialing, the whole thing has become so complicated given the the VoIP applications and all. The simple questions we are trying to answer it. If it is easy to call for a free on one of the OTT applications, why can't the same thing be done for the telecom operators? So to influence this larger ecosystem is going to take time, but the fastest way was to have this kind of an OTT application, which means that there are no resource consumptions other than the data which you use for that. So there is actually no burden on the network. So the idea was to make it cheaper and pass the benefits to the customer, so that the whole thing can be simplified. I hope it answers.
Yeah.
But can I say, when you're using a native VoLTE application, you have those supplementary things like call waiting and other features that is coming in. So are you able to realize those features as well through your link application, or that is not that popular, or it's deemed not required?
No, we are able to achieve most of it. It's just a matter of the software development. In fact, we are able to do a lot more than that, which the traditional voice applications are not able to. It may be unfair to give the exact details here, but there are so many different features which we are able to embed along with the voice, which was not possible in the traditional world.
Okay, and coming to EMS?
Yeah, and coming to EMS, so yeah, that's a very right point you picked up. So what we realized is that when we get the network functions or the network element of our traditional world, to manage those elements, we used to have the EMS. Now, if I go to say 10 different vendors, I have 10 different EMS. Not only I have 10 more different elements to manage in terms of capacity, resilience, interface, so many things. But the biggest bottleneck we found was on our automation and orchestration layer. Because now you have to follow the EMS standards, 10 different standards from 10 different vendors. The effort in doing this is so heavy to get the APIs from different vendors, to interface, to develop, to maintain, testing, big chaos. So what we decided was, let's go to a open standard observability framework, which by using the open interface platform elements, we can connect to all the elements. We ask the VNF owners to just provide the data points in its native format, and then rest everything we manage in the observability framework. This gave us a very, very big strength for the maneuvering, observing, managing, comparing, and most importantly with the automations to have everything under the single roof.
Yeah, so thank you, Hiren, for answering the questions. There are a few more questions on the chat box. I'll take one, and rest I request that if you can just answer in the chat box. The question which I'm taking is about security. The question is that how would you ensure security among network function in a containerized environment? Is there any standard on container security similar to ITSI NFB?
Yes, I want to supplement Hiren on the security issue itself.
Yeah.
Like there is a lot of discussion. Even yesterday, Sahid has posted in social media also. As such, when we talk about 5G, we say that security. I mean, a lot of discussion is there. And coupled with that, this Open RAN has made it more and more discussions are happening. From your experience, this security, is it a big challenge in 5G plus Open RAN, or it is just another day in the life?
No, I think it seemed to be a kind of a threat because now we are opening out, but we did not see any major threat, and I'll tell you why. Because one is that network functions, they themselves have their own security, encryption, and all the layers which are more defined by 3GPP. Over and above, now that the VNFs and the orchestration is controlled by us, all the VNFs are also talking to each other with a TLS handshake. So, which means there is a authorization, and there is an encryption, and there's a completely separate handshake, and one more security layer. And then besides, how you manage the security, that's a very big different concept. But just being pointed to your question, because of Open RAN, we do not see any kind of a specific threat on the security side.
Thank you.
So thank you, Hiren, for answering all the question, and your presentation was really wonderful, very informative, a lot of insight we had. So thank you so much. In the meantime, I request if you can answer a few of the questions in the chat box, which is unanswered, in the interest of time, so that I take the last session of the webinar.
And
Sure.
Hiren, I think you will not be able to stay till the end because of your other engagement. So on behalf of Institute, we really thank for your promptly agreeing for our suggestion and coming forward for this presentation.
Thank you so much for the opportunity. Thank you so much. I'll answer and then I may have to leave. So thank you so much, Suresh and everyone. Thank you.
And Jahid has already answered all the questions which were put on the chat box, and I have also captured in a PPT which I will be sharing at the end to everyone. And now this is time for our third session, that is the Indian perspective of Open RAN, and this will be taken by Mr. Ramu T. Srinivasaiah from Lekha Wireless. And I already introduced to all of you that he's a founder director of Lekha Wireless Solutions Private Limited. And prior to Lekha Wireless, he was associated with Cisco, and he was part of design, development, and deployment of that WiMAX on Cisco P3BS, if you remember. I think my friends will remember that. So over to you, Ramu, for your session.
Thanks. Good afternoon, all. So thanks to speakers, the two speakers who spoke before me from Rakuten and Parallel Wireless. Let me just take a minute to share my presentation. Is it visible?
Yes, it is visible.
Okay.
You can go to
So let me start with a quick introduction about myself. I'm Ramu, the founder director at Lekha Wireless. We have started Lekha in 2010, and I personally have about 24 years of telecom and wireless experience. So I started my journey, as an engineer in dial-up modems. Many of you may remember we were using the regular PSTN line for data network using dial-up modems. So I started my career with Encore software with dial-up modems, where we talked about kilobits per second. And in this company, we developed IPs on the central office side for dial-up modems as well as fax modems. And then I worked for a company called Telecom Communication, where we built ADSL modems. Again, I was actually involved in the physical layer semiconductor development. And then I was part of Navini Networks, and later as an acquisition, part of Cisco, where we developed networks which involved proprietary CDMA and WiMAX technology. And I started my journey, as an entrepreneur and founder of Lekha in 2010. And we'll be talking more about Lekha in coming slides. And this is a quick brief about myself. So going back to, about Lekha Wireless, we started in 2010. We are based out of Silicon Valley of India, Bangalore. And then we have software-defined radio products today, which are deployed for tactical communication. Also, we are one of the leading 5G ecosystem company in India, and also a key player in the ICT field. So just to give a brief about journey, we have IoT networks for industrial application today deployed. And we have deployment of 4G networks for specific use cases, and 5G in our RAN development, which we are currently work in progress. So the key differentiation probably about Lekha is we are a deep tech company with total ownership of software and hardware designs, what we offer to the building the network. So that's a key differentiation. Primarily, the software stacks and the hardware design is completely developed in-house out of Bangalore office, right? So who we are basically, as I mentioned, we have an end-to-end capability of building entire wireless communication system, be it defense or telecom. And we have vast experience of deploying and supporting the private networks. That is our focus. And we are about 210 engineers working out of Bangalore. So who we work with? Primarily, say today, there are use cases in defense where we handle end-to-end, which means the entire network, because they are somewhat different from the 3GPP architecture. But when it comes to 3GPP architecture, we have a clear separation of radio access network, core network, and application layer. So primarily, Lekha provides radio access network, and also we work with core network partners. and as well as we work with system integrators or application developers, where we collaboratively work and take a private network to the market together. So this is how we work with our partners. In terms of a quick information on the industrial, telecom, and tactical network. So these are the three verticals we operate. Telecom is something relatively new. I'll probably talk about it later in the discussion, why we entered telecom late. Rather, we were developing 4G and 5G technology right from the beginning of Leica, but we entered telecom probably about a year back. So that I will talk more about in terms of Vuran perspective. So, and then we are addressing many use cases in the case of 4G. This is how the architecture looks like, and different use cases. Probably now, this is our roadmap for our 4G network, where we are planning to upgrade some of our network, as well as we will be a new entrant to the telecom market with our 5G RAN component. So that will be compliant to the Open RAN. So this is actually covering the brief introduction about company. So let me jump on to, okay, this is one more slide on the SDR products we offer to the defense. So let me jump on to the Open RAN and Indian perspective. So thanks to NTI for giving this opportunity, where I'll be able to talk about what is happening in at Leica in terms of the RAN development, as well as I'll be able to hopefully represent some of my industry colleagues who are into same domain, where they are developing VRAN components. Overall, yeah, it's a majority of it is my personal view. There may be some differences in terms of the exact way each company thinks, but I will try to make it as interactive as possible. Right. So let us look at actually say all my other speakers, the speakers who spoke earlier to me, Hiren as well as Gadiali, both talked about this similar slide. Say, let us look at how a typical radio access network, or the typical 4G network, I mean, typical networks look like. Majority of you from DOT would have been involved right from 2G, deployment of 2G, where we had base station and a core, right? So the base station primarily involved a radio and a baseband processing in a single unit, and which had a RF cable running all the way up to the antenna, right? So this is something which is, so there is also another aspect here. Whenever there was a time domain duplexing, there was a GPS, the time synchronization, and a frequency synchronization that is required. Most of these units used a GPS-based synchronization, right? And if you look at the overall network, say most of the cases, this I'm talking the traditional architecture which we have been following in 2G and 3G, where the entire components, both on the core as well as on the radio, was provided by a single vendor. And it is occasionally, it was the core and RAN came from two different vendors, but RAN was a complete closed box which had the radio, the baseband software, everything packaged in a single unit made by a single vendor. So this was something which was followed, and as we migrated to a newer architecture, the CPRI front haul played a major role in transforming this traditional network to the next generation of equipment. So the primary reason, as my colleague from Parallel Wireless pointed out, is primarily to ensure improved radio efficiency. Basically, these long RF cables resulted in a lot of losses, and the density of the networks got increased, and we want to have better coverage, primarily not only outdoors, also indoors. So we started radiating very high powers from these towers. So efficiency of radio was one of the major challenge which got addressed as part of the CPRI interface. So the whole idea was primarily to improve the radio efficiency and separating out the radio from the baseband processing. So as part of this, what we did was we created infrastructure on the ground for accommodating the baseband unit, the BBU, and also we laid fiber optic cable from BBU to the RRH. So this is how most of our today's 4G network is deployed, where the CPRI interface or a fiber optic cable is the way for connecting BBU to the RRH. And most of the time, there is a BBU sitting probably very close to the tower, carrying the IQ samples, the RF signal from BBU to the RRH. And this is a new infrastructure which is created. So, and if you see the timing reference, basically the whatever we used to do, the GPS. So today the GPS is connected to the baseband unit. The timing information is carried by CPRI front-haul interface, and that is synchronizing all the remote radio head. So what has changed from previous to now, if you can look at, we have separated out radio and baseband unit, and now the RRH is basically a high power radio which takes IQ sample in the form of a digital signal where there are no losses, and there is a short cable between RRH to the antenna, and we are able to transmit, radiate as well as receive signals with higher efficiency. And time synchronization, the GPS is on the baseband unit side, which is probably providing the time synchronization signals for multiple RRX. So, okay, so now we migrated from CPRI to eCPRI, which is another a transition which has happened. So why there was a transition required, right, in terms of CPRI to eCPRI? Primarily, there are multiple reasons in terms of why we are looking at this transition. Hello?
मेरा सिर्फ एक ही सबमिशन है कि जब आपकी एक क्लास खत्म हो जाती है तो थोड़ा सा जो है
Yeah, so yeah, so mainly the packet, the compared to CPRI, the eCPRI follows Ethernet-based IP packets that flow through this same fiber optic cable. If you look at the CPRI to eCPRI, the CPRI required a very low latency. The expectation with eCPRI is it can tolerate higher latencies. The third one is the invention of a packet-based time synchronization protocols, the PTP protocols. That is something which is also a driving force from migrating from CPRI to eCPRI. And also the point-to-point connectivity which was required, if you can recall, say every BBU need to be connected to a RRH in a star network fashion, where we have to run a cable for every tower from BBU to the RRH. It was a point-to-point cable which is getting replaced with eCPRI. Yeah, so this is the thing. So now, is it like, are we using the same fiber optic cable which is deployed for CPRI being used for eCPRI? The cable remains probably the same, but the transport network is something which we have to create a new set of devices, like the switches, what has been used is going to be, it's a new infrastructure which is getting created, which constitutes some of the major cost. Now these switches are PTP aware switches, which are going to be pretty expensive because we're talking of very high bit rate. So one of the challenge eCPRI, when we came up with the industry came up with the eCPRI technology. So compared to the CPRI, where we carried IQ sample as it is, so the amount of bit rate that is required started increasing the moment we start adding more number of antennas. So when we migrate from CPRI to eCPRI, we are talking of four antennas. There are many cases people are talking about massive MIMO in case of 5G, where we have 8 antennas, 32 antennas, 64 antennas, and so on. So this amount of IQ sample carrying over a fiber interface becomes almost impossible. So there was a requirement where we maintain this separation between BBU and RRH, but we have to reduce the bit rate from whatever the IQ sample to the lower bit rate level, so that we maintain the separation where the frequency or standard related stuff, the standard related stuff stays on the BBU side, the frequency related stuff goes to the tower. So as the industry started finding solutions, there were several industry associations. There were several companies who worked on it to standardize. So in the latest form, we have Open RAN Alliance, which is working towards standardizing these interfaces. So this is a brief background. Probably I want to give again, because that helps me in giving the Indian perspective when we talk of many of these transitions. All right. So let me go to the next slide. Yeah, so we are talking of multiple splits from our earlier discussions. Say what was originally a BBU and a RRH. Now we are talking of three devices where there is a RRH, there is a DU, there is a CU, right? So DU stands for distributed unit, which is mostly a real-time system which operates in real time, whereas CU is a somewhat non-real time. Basically, when I say non-real time, it can accommodate higher latency, and it can actually the optic fiber cable can run longer distances. As you can see, I have shared some numbers. Primarily the requirement for backhaul, the latency can be higher, the distance can be as high as 200 kilometers. For midhaul, it is 1 millisecond, and 80 kilometer or lower. And front haul again is far more stringent in terms of latency and distance. So with all these things, what we are talking is there are existing infrastructure which we have already laid the fiber optic network. When we take example of our BharatNet, right? So we have already existing infrastructure which has been already created. So will it suffice for us to create the additional CUDU? Can it rely on the existing BharatNet infrastructure or any other network? So each operator has their own fiber optic network. This is a question we have to ask. Can we actually, so most probably, depending on the quality of the current infrastructure, mid-haul can be accommodated, or it can be a new infrastructure, and front haul will be a new infrastructure based on where we are deploying the DUs, right? So these are some challenges or questions which our operators have to answer. And also, even as a DOT, when we form the policies and guidelines, okay, what kind of things to be deployed? Probably it's an interesting question which is open for larger debate. And is it mandatory to implement all the splits? The answer is no. Already the speaker from Rakuten has already clarified there are different type of devices that are available where we can actually co-locate RU and DU in a single place and just depend on the mid-haul for CU and DU and keep the front haul not required, right? I mean, basically we can put them together. So every scenario, every existing infrastructure and the economics of migrating from the current infrastructure to upgrading to the new infrastructure, there are many factors that drives these decisions. And trust me, these are kind of dilemma or a churning that happens in every operator when they try to migrate. And every region, every country has its own challenges as well as ways of deploying the network. So this has to be addressed through a range of radio access network devices. And there is a huge amount of opportunity for many vendors. And also these standard interfaces which are being created is going to help in terms of bringing this diverse amount of devices from different vendors coexist as a single network. So that's where the Open RAN, I see it as a great opportunity. And probably with this background, I would like to talk about what are the key principles of Open RAN Alliance. Say the Open RAN Alliance stands for majorly three key objectives: leading industry towards open, interoperable interface, and RAN virtualization, and big data, AI-enabled intelligence. This is something which I have picked up from the RAN Alliance website. But primarily, if I look at it, right, say today, if you look at from India perspective, about 3 or 4 OEMs are supplying to close to 4 major service providers. So most of the 4G gears or the 2G, 3G, 4G gears are coming from 2 or 3 different OEMs. And if I look at one network, it involves probably like hundreds and thousands of components involved in it. And we are relying on only 2 or 3 OEMs who are not only OEMs, but also system integrators. So for a country which is as big as India, right, where with the kind of user base, so definitely we require a lot more OEMs playing this role of providing components, and also our service providers or the operators need to have a lot more control over the entire network and as well as elements. So this is my personal view, but I pretty much believe there's a similar thought process exists among majority of the industry experts as well as from at DOT as well. And there's also important from an operator perspective, if I look at it, it's very important they have to maximize the use of off-the-shelf hardware as well as avoid use merchant silicon, not special silicon. Let's say OEM comes with his own silicon, his own software, it becomes completely closed system where you cannot do anything with it. Rather than if a OEM decides not to work with the operator for various reasons, be it they are not interested or they are various geopolitical situation, right? So we end up disposing all the hardware and migrating to a new hardware. Creating a new network is not a small thing, and it's a huge loss in terms of economy. So it is very important. So far, we have been following what is happening in 2G and 3G, 4G. But when we think of 5G network, probably there has to be a fresh thought process in planning the whole 5G network. So that's where we have to think of how we can reduce the dependency in terms of silicon, dependency in terms of the specialized hardware, and dependency in terms of the software. Basically, sometimes some softwares are locked to the specific silicon, right? So these are the questions which we have to answer. Even though Open RAN Alliance provides a standard way of interfacing, but the diversity of the hardware and the software, what we include in that Open RAN networks, right? That's where we get the true purpose of migrating to the Open RAN Alliance. And the third one is specify API, because the first 2 points require a very good standardized API interfaces. And also, it's very important we have to involve all the stakeholders and coming up with these interfaces. If you look at the CPRI interface solved certain problems, but the CPRI interface was mostly a transport mechanism which did not define the message exchanges that happened between BBU and RRH. So because there was a open, it was something like it gave opportunity for people to introduce or the OEMs to introduce certain proprietary messaging, and we could not really utilize that RRH BBU architecture as a coming from different vendor. So this is something probably I can give it as an example why a good amount of standardization is required in order to make it a diversified network. When I say diversified, probably the gears are coming from multiple different vendors and they interoperate with each other, right? So going forward, yeah, probably this is something which is a kind of a complicated diagram, which probably when I speak to my colleagues who are working on the 5G, I keep interacting with them. So the speaker from Parallel Wireless, he has already explained there are various parallel horizontal splits, there are vertical splits. The vertical splits covers the control plane, user plane separation, etc. Right. So if you look at, say, there are many components that are coming into the network, and there are standard interface which are already defined, which are mature. There are some interfaces which are being created. So the question now is, earlier when it was a single homogeneous network, so these separations may or may not existed, but it was something like when I'm developing a network myself at Leica Wireless, so I really don't have to worry about the message exchanges that happens within the, let's say you take any example, within the CU there's a E1 interface. I need not have to worry about how the control plane, user plane talk to each other. But when I talk of Open RAN interface, we have to comply, we have to go through this Open RAN specification, we have to implement these interfaces. So as a company, we have a dilemma whether, so first is I have to develop a 5G network. There is thousands of pages of document where we develop the software, reading the standard, and we build a 5G system. On top of it, there are multiple interfaces which are already specified by 3GPP. We comply to it. But now there is an Open RAN interface, which is actually talking about interfaces within the system among the components. So then there has to be a kind of it's an additional work, but this additional work demands a reasonable market access, which is very important to encourage new players into the market. So this is the question which is like we have to answer as when we form the policies in India, right? So it is quite complex and time consuming to implement all these interfaces, as well as hardening it, because it has to meet all those carrier grade requirements. So it's very important. Yeah, we have to put those extra effort in implementing the Open RAN. And today there are a lot of companies, and I will be sharing further details of the companies who are working on ORAN and who are developing ORAN based products. So if the industry feels okay, the industry definitely feels it's a long term. There is a long term reward for adopting Open RAN for Indian telecom network, which probably DoT should consider seriously. Primarily because this gives two things. One is our networks are going to be open, and it will not be locked to a particular vendor. And also it gives a window of opportunity for all the Indian players to come up with individual components, because if you are a big company, you can take care of the entire components. But when we want to actually, we are a new entrant into the telecom, so there are many companies who work on different components. They can bring their components, plug into the network. So this requires certain amount of preparation. Basically, like probably I will cover that. So this is a quick list of companies who are working in Open RAN. Like there's a Big Cat Wireless, Lekha Wireless is about whom what I'm representing. Resonance, Sankhya Labs, Signal Chips, Sukta, Tejas, VVDN. So basically all these people, because I have an interaction, I have listed them, but there may be many more companies who are working on Open RAN based products, RUCUDU. And so this is a quick heat map. And also it's a growing ecosystem in India. So what I'm suggesting is, yeah, it is something which is a growing ecosystem for implementing ORAN. So from an industry perspective, from a technology perspective, there is a lot of work that is happening, which is a very encouraging thing. And looking at system integrator ecosystem, basically I got this list from SRI division of Department of Telecom. So there is a good amount of system integrators who are coming into the play, similar to the Rakuten, emulating the Rakuten kind of integrators, and as well as use case developers. Like there are many more, right? So so I'll probably summarize my talk based on the overall what has spoken about Open RAN. So Open RAN primarily is trying to standardize the messaging protocol across different components. And these four components, these components primarily is categorized into four planes: C plane, U plane, S plane, and M plane. So I'll not get into the details of it, because this discussion is primarily towards presenting the Indian perspective. So for companies like Lekha Wireless or similar companies, say the C plane, U plane is something which is very simple, because it carries some control information, and U plane carries actual IQ sample data in a different form. And S plane is a time synchronization, which is we can actually, it's a there is a way we can evaluate the performance. But when it comes to M plane, is something which is, there are many different interpretation. There is a clear dependency on M plane messages, because here there is a scope of things can become proprietary in nature. So we would require definitely a good amount of support from our operators, where they open up their network. We start working together as a single ecosystem in India, where people who are developing the Open RAN component, they bring their equipment, they plug to the network. We create a kind of a deployment bed, where the different companies can come and plug their equipment and test it. And also we can evolve together a complete Open RAN network together, along with system integrator and the operator, right? So this is the point number 3. And then, so there is a lot of amount of hard work that has to be put by the component developers, because there is a good amount of interworking that is required, and compliance to the interfaces. So today companies are investing in ensuring compliance with respect to 3GPP. These equipments are very expensive. Additionally, we are now expected to comply with Open RAN interfaces. Again, there are new equipments that are coming in. So to make a mature ecosystem, we need to invest a lot in terms of test and measurement equipment. So here DoT can pitch in, as well as operators can pitch in, and also system integrators can play the role of putting them together. So this new generation of system integrators are key to the success of Open RAN ecosystem. Because say, if we talk of an Open RAN network and the entire network comes from a single vendor, then we have not changed anything. Like we are from India perspective, I think we should look at, is it a diversified network or is it a disaggregated network? So to make it diversified, it is important we have to follow disaggregated network where components are clearly, there are separate components with standard interface. That is step number one. The step number two is the diversification of the network. Here comes the role of system integrator and operators, as well as the component developers within the country. So with these three positioned in the right place and supported by DoT in terms of policy and the planning, we can actually enable 5G networks, which we can build a self-reliant 5G network going forward. So with this, I will end my presentation. I would like to ask for any questions.
Yeah, thank you, Ramu, for wonderful presentation, and also you told us about the Indian ecosystem working onto the Open RAN side. There are few questions, and there's a raised hand also. So let me take one question. One question is by Mr. Sudhakar. With eCPRI and PTP, are you able to remove GPS dependency?
So see, the time synchronization is what is required in the case of why we need the PTP protocol is primarily in terms of eCPRI. Today, our products support both PTP as well as GPS synchronization. So in case if the operator don't want to upgrade immediately with PTP aware switches, which is going to be expensive, so we provide an option of synchronizing through GPS. Using our internal clock. So we discipline our clock with GPS, and it is definitely handled, yes.
Yeah, thank you. My DDG Sunil sir has raised the hand. Sir, you can open your mic.
Yeah, Ramu, thanks for your very good presentation. I just want some clarity from you. You mentioned about this split options that are available in this Open RAN architecture as well as in 3GPP. So whether this has resulted in different diversified applications getting evolved, like small cell forums coming with some kind of, so what are the different advantages that has been actually realized by having various split options? Can you give your perspective?
Yeah, so I think, yeah, I could have used a picture, but okay. Basically, the need for different splits primarily came from the infrastructure to be created. Basically, when we talk of why we first we have to ask fundamentally why we required splitting the RAN compared to our traditional network. So the reason for splitting the RAN was primarily to virtualize the RAN, wherein we can bring in many flexibility to the operator. Number one. Number two, can we start utilizing non-specialized hardware? Number three is basically, can I bring in certain special algorithms like AI, ML, wherein like we can reduce the cost of operation. So these are some of the motivation for virtualizing the RAN. And this resulted in, okay, exploring where can I split. The key objective for splitting is how do I reduce my bitrate requirement, and can I make it tolerant to the latency. So with this, there were many ways of splitting. In fact, small cell forum was way early in terms of Open RAN. They started defining a split. Today it is called as option 6. That actually splitted the system into two parts, which is layer between layer 1 and layer 2. So that also had a good amount of tolerance. So now the question now is we have to ask ourselves in India, like how much of our fiber optic network is tolerant to the latency, right? What is the latency? What is the kind of throughputs we are achieving with existing infrastructure? If the answer is no, then we cannot be following. Either we have to be ready for spending extra money in upgrading this infrastructure, or we have to actually think of a split which actually makes sense for our networks. So again, this question changes when I deploy in an urban area where the cost recovery is a lot faster. But when it goes to rural, again, creating a new, already the current infrastructure we are lagging, and creating a new infrastructure is a bigger challenge. So it is very important while we comply to the Open RAN, we have to be judicious in selecting the RAN splits.
Yeah,
I hope I answered the question.
Okay, yeah.
Yeah, thank you, Ramu. And there appears to be no more questions or raise hand. And there was certain question to Mr. Hiren, who has left because he had some meeting. So he will provide us the answer, and we'll be able to pass on to you, because we have the email IDs of all of you when you register. So we'll be sending you all the PPTs of the 3 sessions, as well as I have jotted down question answers to that piece, and also we'll try to take answers from Mr. Hiren. Few of the questions got unanswered because he had to leave. So with this, we are coming to end of the session, and now may I request Sri Atul Sinha sir, who is DDG admin at NTI Prit, for a formal vote of thanks.
Thank you, Ashok. Thanks to you. Respected Member Services, Digital Communication Commission, Shri Deepak Chaturvedi sir, in absentia, probably he has some engagement. He may not be able to join this concluding session. Senior DDG and Head of National Telecom Institute for Policy Research, Innovation and Training, our institution, Shri U.K. Srivastava sir. DDG Wireless Access of NTI Prit, Shri B. Sunil Kumar sir. Mr. Ashok, Director NTI Prit, and extremely distinguished speakers, Mr. Zahid from Parallel Wireless, Mr. Hiren Joshi from Lakutin, and Mr. Ramu from Lekha Wireless, and a large number of participants of this webinar. A very good afternoon to all of you. It was indeed a pleasure listening such a wonderful discussion by all the great speakers who participated and who had really shown the roadmap of Open RAN system for the audience, for the participants, and also for the industry of this area, telecom domain. You all will agree that innovation is the key driver for Industrial Revolution 4.0. And I believe that Open RAN is one of the biggest innovation that is in offering today. And India is going to take its lead role in telecom manufacturing domain through Open RAN. That is what the opinion and expectation and wish of policymakers of this country is. I, on behalf of NTI Prit and also on behalf of Department of Telecom, would like to request all the participants here to take this deliberation that has taken place from this platform forward in the direction of making India Atmanirbhar when it comes to 5G, and I think Open RAN could prove to be the biggest initiative in that direction. I would like to take this opportunity to convey my heartfelt thanks to Honorable Member Services, Digital Communication Commission, who, despite getting tired of his last night travel, spared time to inaugurate this webinar, very important webinar. Thank you so much, sir, in absentia. We'll convey Member Services, Honorable Member Services, this thanks to him. We are also thankful to Senior DDG and Head of NTI Prit, Shri U.K. Srivastava sir, who has been the constant source of inspiration for all of us for organizing such very pertinent and relevant seminar on such relevant topics, which give a direction to the entire telecom industry towards doing something really great for our country and towards evolving the new standards which can help this country and the whole telecom fraternity towards the progress and towards the development, what we call Industrial Evolution 4.0. I would also like to take this opportunity to thank Shri B. Sunil Kumar sir and Mr. Ashok Kumar for organizing and arranging such wonderful speakers who have given, who have really explained their thoughts so very well about the Open RAN, how industry is moving, what are the different thought processes going on into the industry. I think that would have created a lot of clarity in the mind of participants that how this is progressing and how very close we are to see the light of the day. This whole concept of Open RAN, how close we are in getting really realizing it onto the ground. And the biggest thanks is due for our very, very distinguished speakers. On the first place, Mr. Zahid from Parallel Wireless. Mr. Zahid, thank you so very much for introducing the topic so well, giving a definition to Open RAN and in your personal capacity also, and in general, what has been done in this area. Mr. Hiren, we know that Rakuten is has taken a lead in this direction, and you have very well defined, explained that how the standards are moving in what direction and how standards are close to realization. And great thanks to Mr. Ramu of Lekha Wireless for showing us the stake of Indian industry and how well Indian industry is trying to work it on and to take it forward for Atmanirbhar Bharat. And we would like to assure Mr. Ramu and everybody here that Government of India is fully committed, and Department of Telecom will leave no stone unturned to make the policies which are which provide a very, very conducive environment for the growth of ORAN, because that is having the biggest chunk of the entire 5G industry, going to have biggest chunk of the 5G industry, and Government of India is really, really committed to. So thank you very much to all the eminent speaker for clarifying everything so very well. And last but not the least, the biggest thank is to the more than 300 participants. At the peak time, Mr. Ashok, there were more than 300 participants, and that itself reflects the kind of interest that has been generated in this wonderful topic of Open RAN, because this offers humongous opportunity for small as well as big players, for a small time innovator to big companies innovators to play their role and grab the pie in the big telecom market. Thanks to everyone at last. Thank you very much for such a wonderful organizing such a wonderful webinar on such relevant and pertinent topic, Open RAN. Thanks everybody. Thank you very much.
Thank you, sir. Thank you, sir. With this, we have come to end of this session, and with permission of chair, I would like to close the session, sir. Do we have permission, sir?
Yes, may I close. Thank you very much.
Yeah, thank you, sir.